Okay, so I've got two more examples I want to look at. Just again, using our calculator and just showing you again, kind of almost the expectation of what AP Exam wants for you on the day of the exam when you are allowed to use a calculator. So one of the things that you have to always pay attention to is what are you actually given. So in this case, it says the first derivative is given by this, and it's already the first derivative. So we have to kind of make that mental note. So when it's asking you how many points of inflection, right? So we know points of inflection are a second derivative test, but the fact that you already have a first derivative means we only need one more derivative. So I'm going to go ahead and put that into my calculator. And I have like an online version, if you remember, x minus 4 e to the x. Let's see. So x minus 4 e to the, I thought it said, shoot, no, what did it say? E to the negative sign of 2x, my bad. E to the negative sign of 2x. And it should, just so you remember, that you should always be in radian mode when you're dealing with trig. Okay, so x minus 4 e to the negative sign of 2x. And then my window, we said 0 to 2 pi. So we're looking on one complete revolution of the unit circle, although there's a frequency of that fact that there's a 2, I think, in our function. So it's going twice as fast. So we actually will get 2 cycles. But how this is dealt with this e and this x minus 4, we shall see. Now, remember, we said we only wanted a one more derivative, and we don't need the function turned on. So let's go ahead and turn that off. And I should check my window since we're looking for points of inflection, and you're going to look at the second derivative graph. That means for your y min and your y max, really negative 1 to 1 would be perfectly fine because that'll allow you enough of a window to see that it crossed the x-axis. So again, it might take some time because it's thinking, right? And it has to go through 2 functions even though we only see 1. So we have crossing points 1, 2. There's 3. Probably one more, I'm guessing. 4. And then you know it's done because because your little thing up in the right-hand corner has stopped showing that it's processing it. Now, again, why do these things work? Because if you remember, a point of inflection is where the second derivative changes signs. So if you're actually crossing the x-axis, positive, negative, negative, positive, positive, negative, negative, positive, then you know that those are points of inflection. Now, because there's no because we're looking at a second derivative, we have no idea if the first derivative is equal to 0. So we have no idea if any of these are points of inflection. But if you wanted to, so you certainly could graph just this if this represented the first derivative. And we're interested in just, are any of these saddle points, then you'd have to have one of these bounces happening right along the x-axis, which it does not. So there's a great way to test that none of them were points. None of those points of inflections were saddle points. So there were 4. And then so we answered that question. Very good. Now, the next one says, here's a function, and let's find out when is the slope of this equal to 3. So let's go ahead and type in 2e to the 4x squared. Oops, sorry. So go back to y equals. So 2e, 2 times e to the power of 4x squared. Okay. And we're interested in where its derivative is equal to 0. Or not 0, I'm sorry, 3. So I'm going to turn the derivative on, turn the function off, and then I also want to know when its derivative is 3. So I inputted 3 into y4, and I just want to see when those intersect. So I have to change my window slightly because I'm no longer needing from negative 1 to 1 because I'm not looking for where it crosses the x-axis. I'm looking for where it crosses 3. So I definitely need to go up that high. 0 to 2 pi is not necessary. If you think about the shape of an exponential function, as soon as you basically cross into positives, you are increasing dramatically. And the fact that it's like 4x squared is going to go even faster. So I'm thinking maybe like 3 would be plenty. So let's hit graph and see what happens. Yeah, oh wow, 3 was way too much. I gotta get run with 1. So we're gonna wait a while, and then 1, 2, 3, we're gonna wait to see where it crosses right there. And that would be the point of intersection. Perfect. So we do second calculate, and we pick intersect, which is number 5. Now it asks for the first curve, and it's telling you it's y2, which is the derivative function, and the second curve, which is 3. It asks for a guess. So here's the thing. You really don't have to guess unless you have more than one intersection, because it needs to get the cursor to the closest intersection, or the closer intersection that you're looking for. But if there's just one, it's not going to matter. It's going to find it. I'm going to guess, though. Let's see. That looks like point, let's say it's 0.2. I have no idea. I'm going to guess 0.2 as my guess, just for fun. So we can see and hit enter. And it's finding the intersection right there. Oh, a little over 0.168. So I'd write down 0.168. And then there it is, 0.168. Okay. So remember, actually, I don't know if I've talked about this, but when you are giving a decimal, they don't care if you round or if you truncate. Okay, so you have a little bit of liberty there, but you must give 3 significant figures or 3 decimals. So that's why I did that. Okay, so hopefully those 2 examples help. Continue working on the homework and come in if you have any questions.